Hello, everyone, and thanks for joining us here today. Our webinar is on 5 design tips for remote monitoring, presented by Paul WACKER and moderated by myself, Oliver Wang. Just a quick note for those of you who may not be familiar with Moxa, we specialize in industrial communications and have been in business for over 30 years. Basically, if you have something outside of the home or office that you need to connect to a network or the cloud, we probably have something for you. Feel free to contact us at usa@moxa.com or visit our website if you'd like to learn more. Now, if you have any questions during this webinar, submit them in the questions pane, and Paul and I will try to address them during our live Q&A at around the 45-minute mark. Don't be shy. We want to hear about what you're facing out there on the front lines. So, without further ado, that's it for me. I'll go ahead and hand it over to Paul to get us started.
Excellent. Thanks so much, Oliver, and thanks to you joining us today. I know you're busy, and aren't we all today? Appreciate your time, and we want to make sure this is productive for you. So I think you'll find this, a great use of your time. About the topic, maybe just say a few words before we get rolling here. When we talk about remote monitoring, our thoughts on designing this event was to kind of collectively do multiple things. Some of you may know it as remote monitoring. Some people may think of this as SCADA. Some of you may be a little more progressive, maybe see some crossover with Internet of Things type applications. They're all about being able to extend the reaches of your factory floor or your plant, or in some cases extending those connections to multiple sites across states, across countries, and the world. It's an incredible place we have today with IP networking for them. Whether you're maintaining an existing project and it's been underway for a while, or whether you're kind of working on a new project, we really hope to share some best practices with you. And we're going to cover a pretty broad area. I'm hoping that for all of you that are joining us today, I know you're a pretty diverse crowd, I hope that each one of you can take away some things for further thinking, maybe some tips to help you in designing new systems or in maintaining systems, and really some takeaways that can help you be more productive in your job and to benefit your company with that. So anyway, we hope it's helpful for you, and I'm really excited here to be with you today and take you through a little bit of some of our best practices. With that, why don't I go ahead and open up here first, and what I'd like to do at the beginning of this, and Oliver, let's go ahead and open the poll. Because of the diverse crowd, I'd really like to get a little feedback from you folks today, and this helps me to tailor our presentation a little bit. So I know you come from diverse areas, but why don't you help us understand, and we'll be sharing this with the whole group. Well, what are your top challenges with remote monitoring and SCADA? And we've got a couple selections for you up there. We've tried to capture, kind of some of the things we commonly see. And this can be multiple choices, so you can check more than one, since I know it's usually more than one challenge that you have. The first one, diverse field devices and interoperability, right? How do I get these different things connected? A lot of you folks probably have had or maybe continue to have challenges in getting those devices connected. We talk about that last mile connection. That's maybe not a mile, but maybe that last couple of 100 feet in some cases. Do you have those challenges? Some of you may be currently using or contemplating using wireless connections, whether those wireless connections be 900 megahertz, Wi-Fi, cellular, satellite types of technologies. Let us know if that's a challenge. A big one, particularly in the last year or so, network security. Does that impact you? And lastly, and we'll probably touch on this a little bit today, that collaboration between IT and operations, with operations being kind of broad from, engineering and maintenance, you guys that are responsible for keeping the plant floor running for those. How are we doing, Oliver? Are we kind of close to closing this one out?
Yeah, let's go ahead and take a look at those results. Thanks for everyone participating, and let's.
Great. So we've got a pretty good diverse mix, and we kind of figured this one. So kind of across the board, and I guess that's great because we're going to address all of those issues as we go through the webinar today. Excellent. Thanks so much, Oliver. Send me back to the slides. Perfect. From there, let's go ahead and move on and get into our first area. And our first area is kind of just summarizing some of those. I think you kind of saw a lot of those pain points. I'm not going to spend a lot of time here, but it's pretty diverse. And I think with the 5 key things we're going to talk about today, we can address almost all of these on this that you've identified with today. So let's start off with number 1, and there's not a particular order in terms of importance. It'll be different for all of you. But I think, and particularly in the new design stage, when you're doing an upgrade to an existing system or embarking on a new project, you really should spend some time about, what is the means for communication that we're going to try to standardize on. So I characterize this as choose the right communications protocol. When we talk about communications protocol, I suspect that, in our experience has been that most of you are probably using Modbus. It's really been the de facto communication standard for on the plant floor, across the campus, even wide area networking have been very popular. There may be some of you joining us today that come from the utility segment that may have some experience with DNP. Very similar in what both of those do. And just as a quick refresher, I know we usually have a mix on this. Some of you may not know those protocols. Both of those tend to, or architected in a way to have a master-slave or client-server type of response where a request has to be made from your central location out to the field devices. So the request is sent out and the response comes back. The difficulty with that is only one field device can respond at a time, and you've got a situation like this that your polling period depends upon how long does it take to send that request, how long does that device take to process it, how long does it take to transmit that message back, and is there any turnaround time delay that we have to wait between those polls? You take that time and you multiply by the number of sites, and you may have, using some examples from oil and gas applications for wellhead monitoring, which can be very large in terms of several minutes, to water, wastewater applications to others. That can be quite a lengthy process for that. So you probably know some limitations of these poll types of systems. Nothing wrong with Modbus. We use it a lot. It's still a workhorse. But it does have a couple of limitations or caveats, if you will. It's that sequential processing that's a problem. So you've got to, kind of design your system carefully and plan for the future to make sure you can get the response time you want, because updating the data values at your central site depends upon how quickly you can get to all those field devices. And so things like, how many devices you're connecting with, how much data you pull, what the response time, if there are communication faults, those all take some time. You also need to think about this, and when you do a DNP 3 or Modbus application, you're always polling that data whether it's changed or not. So if I'm looking at a lift station on a wastewater application, and that level height for the well is not changed in the last 15 minutes, I'm going to poll it regardless. I have no way to work around that. So you got to think about those types of things. And of course, the rate that you can update data depends upon how much data you're polling. And then for some of you probably have a pretty good understanding of this. If you are using cellular connections or wide area networks or even satellite types of connections, most of these have a usage-based model. So you're going to pay some amount based upon the amount of in-transit data for that. They can be kind of complex models. That means you have to think about what's that monthly operating expense for this in terms of how many devices am I monitoring, how much data am I pulling from those devices, and how quickly can I update that data for those. So this goes with any polled system, whatever the protocol is, even beyond just Modbus and DNP. So one of the interesting things is another way of doing this, which many of you may be familiar with, using the concept of report by exception. You may hear the word data change. Some of you, like myself, I come from factory automation background. If you've seen a control area network CAN, which some of you may know as a very early implementation of that from DeviceNet, or some of the Ethernet technologies like Ethernet IP, these use this concept quite heavily in that each device is able to share with anybody on the network information, and that information is shared when the data item changes, right? So if we're looking at that tank level and that tank height only changes maybe once an hour, the data change only happens once an hour. So it's really an interesting technology. And the benefits of this type of architecture means that you're, instead of pulling data, which is kind of like polling, you're pushing. That minimizes the data transfer. That means you get immediate data updates. You don't have to pull them. The caveat is not a lot of protocols support that now. Some of you using DNP, there's a mode of DNP that can do report by exception. Also, in the latest versions of OPC-UA, there's a pub sub, meaning publish subscribe, that has some features to implement this. So some interesting things to look for in some different ways of doing things. I want to take this a little further and talk about another protocol that has maybe a little more acceptance in IT and in terms of industrial Internet of Things. It's a protocol called MQTT, and it's kind of interesting because its acceptance has been more in terms of IT, but its roots really go back to industrial automation for pipeline monitoring, dating back to about 1999. And it's a protocol that's built upon TCP/IP and utilizes this concept of push-type notification instead of pull. I'll share just a little bit of insight with you if you're not familiar with it, that utilizes publish subscribe. So you might hear the word pub sub used for that. The really interesting thing is we're seeing a lot of interest in this, where it's kind of bringing both the operations and the IT teams together. And one of the reasons that IT's been so supportive of this, it works a lot like the technologies that they've been using for the last 10 years for enterprise service bus and ways of messaging in large transaction processing systems. And just to give you an idea of how robust this is, any of you that are Facebook junkies that use Facebook Messenger, MQTT is a foundation technology that's powering Facebook Messenger. But it's not just an IT technology that's great for mobile devices. It's actually being deployed in a lot of different industrial deployments in the last several years and gaining some huge popularity. So why don't I just kind of give you a little bit of key concepts on that real briefly, and I wish we could go into more detail, and maybe this is a future webinar topic, but it uses a couple of concepts of, number one, a client device. This might be a PLC or some edge gateway device that's able to collect data and share it. So you have to have at least a client device. But one of the unique things is there's this concept of a device that could be software on a PC, a software on an industrial computer called a broker. And the broker is basically a message router, and its capability is being able to move messages amongst those client devices. So as you can see here, something like this is probably not useful unless we have some data. So a data item such as I pictured here on the left with the little temperature icon, a data item is referred to as a topic. Topic is a channel of information, kind of like a radio channel. If you want to tune into something and get your sports station, you're able, or tune into whatever you like to do for online streaming, you're able to get specific data. In this case, we're going to be talking about temperature. And then we probably want to have another client. It's not too useful if you can't share that information in something, so you can have multiple clients in an application like that. And then just to kind of finish up this real simple concept example, you'll hear about the concept of subscribe. That is the action of a client requesting to the broker that I'd like to know that temperature. And it could be one device, it can be multiple devices. There's even support for wildcards, which can let you subscribe to a whole tree of information with that. But this is the way for the client to ask the broker for permission to accept to receive that information. And then the exciting part here is now we've got data at that client. The client on the left has said, hey, temperature has increased by, let's say, 1% that's determined by the client. That client can then publish that to the broker, and the broker takes the role of distributing that to all the clients. We've done a real simple example here, but I think you get the idea of some of the different architecture of this type of system as opposed to those more conventional SCADA applications with polling. And there's a lot of really interesting benefits to this when we look at how that works in an overall system. So just to summarize a few and give you guys just a little bit of insight into why there's so much talk about MQTT and why so many people are excited about it. You know, that report by exception means that you're going to send data when it changes and not just pull stale data on that. And if you want to get in and look at the bits and bytes flying across the wire through the air, it's a really super lightweight protocol, which means it doesn't take up a lot of bandwidth. And this is one of the reasons that folks within the oil and gas industry have adopted this is, you know, on satellite links or areas where you're going to use cellular, you know, backhaul to get that back to, you know, the central location. It can be really efficient for that, and that report by exception cuts down on your data costs. And the part that I think is really exciting for IT is that one-to-many messaging model where anybody who wants to receive the data can subscribe to that specific information and be able to receive that. And that can even be a read-only basis, so you can read data but not have any way to change it. I'm oversimplifying here, so please understand there's a lot of security and permissions that are possible to do on this. There's a lot more under the covers once you kind of, you know, peel back the layers of the onion, and you can see some of that. There is quality of service, so you can be sure that the message gets delivered at least once or only once. And the biggest thing that I'm finding is, as we're talking to different people about these technologies, is the flexibility of decoupling the devices from the applications. This is what IT found out about, you know, 10, 15 years ago, of being able to have different enterprise systems share data by having a messaging platform for this. So I'd encourage you, if you're interested in this, please take a look at more about this. MQTT.org is a great place to go for information. It's here on the lower part of the screen, and there's some great resources to you. If you like to experiment and you like to play with, like, say, a Raspberry Pi, and there's a great broker called Mosquito. There's great resources on this site to learn how to do some of those things. Okay, let's move on to number two. Number two is, you know, we like to be able to choose a main protocol, but the fact of it is you're going to handle devices that don't support that protocol. So, you know, think about how to handle devices with other protocols. So sometimes those might be media conversion. You know, when you get out to the edge of the network, you're going to find a lot of different devices. You know, sometimes they might even just be discrete I/O that you're trying to get connected, or maybe they're going to be serial-based. Our experience is a lot of serial devices. You know, you might need to convert those from a media conversion, from the physical format connection. More than likely, you may also need to do some protocol conversion. Lots of options out there. I'd like to share a couple of options with you. You know, protocol can be really hard. A lot of people will throw an industrial computer at it, spend a lot of engineering time to write their own custom gateway software, and there are some easier solutions to that. For that first one, we see a lot of folks that, you know, and maybe some of you younger engineers out there today that haven't had a chance to learn from some of your other coworkers that have had some experience from years back. There's a category of devices that are really cool. The IT guys call them terminal servers. Some people call them device servers. Some people say serial Ethernet. But it's a small little box. You can see a couple examples of units up in the upper right-hand corner that can take a RS-232, 422, or 45 device and quickly get them on Ethernet to be able to grab that data. These are kind of interesting because they're a total plug-and-play device. In about 15 minutes, you can set one of these up. And these work on the concept of just basically taking that serial data, putting it into a UDP IP or a TCP IP packet, and helping you transport it across the network. These can be great solutions if you're strapped maybe in a factory automation application with some legacy applications that have to use COM ports. There's even a driver that can be used that's a software-only solution to be able to have that software access that over Ethernet. Great solution. However, this type of solution is agnostic to protocol. It's kind of like the conference bridge we have today for you folks to dial in by phone or via the web. We all have to speak the same language, which is English. Unfortunately, I'm not too multilingual, so you kind of get the idea of how this works. If you have to bridge protocols, you know, please remember there's some great devices out there that eliminate the need to use an industrial PC for this, eliminate the need for expensive plug-in modules that go into a PLC. We've got a lot of folks that like to use these with the variable frequency drives. It can be less expensive to use a single gateway than to have to put in communications adapters and all those VFDs. And these are great ways to do that. They can be transparent gateway, which you just set up a few things like your IP address, set up your communication speed on the serial side, and that works really great for Modbus and DNP3. When we have to convert between multiple protocols, when we talk about protocols like Profinet, Ethernet IP, Modbus, TCP, these active gateways are really great. To give you a little insight into how they work, they're really kind of simple. Basically, you're going to have two things. Let's say our SCADA system is Modbus, and we want to be able to get to something in the field that's maybe Ethernet IP or Profibus. We drop in this gateway out there, and this gateway has a little bit more setup. This is the active gateway, so you've got to put a polling table in here to say what you want to collect. So you'll build a table that says, I'd like to pull up, this specific device. The device responds, and we refresh that input table, based upon a little poll cycle. And that's held in a dual port memory inside the gateway. And then your SCADA system has the ability to be able to poll at any time to capture the most recent data and then bring that into the system. So it does require a little bit of setup, but this can be a nice solution on some of those applications to get an odd device out there that doesn't conform to the standard of your SCADA network to easily do this. And these are really inexpensive devices that are just a couple $100 that, when you look at your time, how busy you are, it could be some great cost savings for that. Okay, great. We're moving along pretty good here. Let's get to item number 3. So number 3 is, networks have gotten super reliable in recent years, but the problem is things can happen. We know that guy Murphy that's lurking out there, right, when we least expect it. So I'd like you to think about this as plan for communication disruptions. There's a lot of simple things you can do, and we're going to touch upon a couple little thoughts and techniques, certainly things to think about as you go through that. In this part, think about secondary backup networks, right? That might be on the site itself. Think about redundancy in your communications path. This is one of those great reasons to think about maybe you might want to use a managed switch instead of an unmanaged switch. Managed switches allow you to have redundant connections for that. This could also be done via router in some cases for that, right? Some of you might be using wireless technology. In terms of wireless, and it might even be a combination of these two, we see a lot of applications where the primary path is wired. These are mission-critical applications, and sometimes they might want to have a cellular backup for that. You can have both, and you can design very robust systems doing this. And even in the cellular, you need to think about things like signal coverage. Where are we going to put that antenna? Monthly service fees and usage fees on that are on that. Specifically for that, a couple things to think about that aren't intuitive to a lot of us, especially if you haven't done this before, is think about what might happen with your carriers. So fortunately, there's pretty good coverage. Major carriers here for at least for the U.S., which covers a lot of you joining us today. 2 carriers, Verizon and AT&T. Think about your devices that maybe can support both carriers. So maybe your primary network is going to be AT&T, but let's say something happens to that cell tower that you typically use, and there's not any other towers in the area that you can get coverage for that site. Wouldn't it be nice if you could back up to a secondary network? So when you're talking to your suppliers, question them about having the ability to have dual SIM support and be able to support multiple carriers. One will be primary. The second one will only be for backup purposes on that. Likewise, most of the companies providing communications products and even industrial control products, they don't always build all of the parts that go into these. So a lot of these are using commercial off-the-shelf modules for this. So it's really important that those suppliers have a real robust mechanism for recovering those connections. And a lot of things can go wrong with cellular. Talk to your supplier or your potential supplier and make sure they've got a really good strategy for handling this. In the event you saw of having dual SIMs, that's important. But what happens if you lose the cellular connections? What's that recovery mechanism look like, right? This is where you'll see a big difference in cellular products. The more commercial ones that you'll find for consumer use don't do any of this, and it's all a manual process, and that's the worst thing that can happen to you when you've got a site that goes down that's expecting a human to be there at the end of a laptop to click a button to reconnect. So lots of things to think about here. And likewise, and maybe some of you have this experience, think about what happens if you lose that connection, right? How are you able to keep that local site running? So I just kind of a placeholder here to think about. What happens if you lose a connection? Can you do a controlled shutdown? Is there enough intelligence at the edge site to do that? Can it function for a short period of time to do that? Some of this may require some simple sequencing and logic. Some of you may have PLCs and RTUs in those sites which can do some of that. Some of you may use a smart relay or some other device to do that. And if you're not a programmer and this is a challenging area for you, don't be intimidated. There's some really great products out there in the marketplace right now that even if you're not a programmer, simple if-then-else type of logic that can handle some of these things until the network connection comes back up for that. Okay, great. Oliver, I'm going to ask your help again here. Let's open up again here and see how we're doing and do another poll, if you will. All right, great. So you might see our next topic coming here. How are you prioritizing network security for your operations? So give us a little feedback on that. I mean, this has been a hot topic the past couple of years. And again, select one on this one if you would. So please think about which one is the #1 priority for you. So some of you, be honest, there's no shame in that. We're all learning about this. We haven't addressed this issue yet for #1. #2 is maybe a little bit, so we have some guidelines, and maybe this is for some of you that are just starting to embark on this process. The third item down, we have established procedures, and we even do audits regularly for this, right? A little more established and practiced within these organizations. The next one is security is treated as a critical priority for all of our business. That's somebody that's been doing this for a while. And also that usually tells me that someone has have good collaboration between IT and OT, and they're being able to share best practice on both sides of that partition. And then lastly, this one's a little bit of a tongue-in-cheek, but I let IT worry about security, okay? But if you feel that way, it's okay to share. Oliver, how are we doing? Can we go ahead and share some results?
Yeah, it looks like we got a lot of votes in, and we'll go ahead and share where our audience stands on this particular topic.
All right, great. So we got a little bit of feedback, and we're sharing this with you so you can kind of see what the consensus is out there in the community with that. And I kind of expected this. I'm really good to see that the fourth item down, security is treated as a critical priority. I think if we would have done the same poll maybe a year ago, that would be very different. And one of the things we're going to stress is collaboration. This is not something that's easy to achieve, and it really takes a business objective. And I've seen in the best organizations, and Oliver, send us back to the slides, and I'll talk through this. One of the things we've seen is organizations that embrace this across the organization really kind of do the best job at this. And for those of you who responded, congratulations, you're doing a great job if you feel that you're really treating that. So #4 is don't treat security as an afterthought, right? So in other words, design in security from the start. It's really hard to do this if you don't, and it's more work in that case. So there's a lot of people I admire and a lot of people I look at out there in the marketplace. One that is really interesting to follow, his name's Bruce Schneier, and he's a IT professional that's been really focused on security. And this is a little bit more IT-ish, but I think this quote really strikes home. He says, the reality is that security is not something you can buy, it's something you must get. Right? So don't be misled to think that you could go out and buy an appliance, you plug the appliance in, and now you're secure. That's so far from the truth. And this really means that you need to have an executive team in your company that embraces this, and to really have the different parties within your company come together to work on this as a shared goal for that. So let me share a little bit of this with you. We have done from time to time a webinar exclusively on this. So if you'd like to see this, make sure to subscribe and look for other webinars. We can go more into depth on this. I'm going to try to paraphrase some of that seminar here and give you guys kind of the highlights in maybe about the next 5 minutes or so. And the two standards that we see spanning all of the industrial areas kind of fall into two areas. If you're involved in utility type applications, water, wastewater, grid, anything that hits, you know, state, municipal type of thing. Certainly NERC CIP is one of those areas. It's very much centric to power, but there's some great thinking in that space and a lot happening there. The one that I think we probably spend a little more time in is in this other segment. Some of you that know about the ISA, great organization to do professional education and also to kind of help bring us together as users and suppliers to establish new standards. They started a work group many years ago called ISA 99. That has kind of come from a US-led initiative and has become an international standard that some of you may know as IEC 62443. So 62443 really kind of took some critical thinkers, brought them together to kind of break this down into a couple of building blocks that I think make a little bit of sense. So let me try to take you through a little bit of that. And I think the most important thing to understand in this segment is and this kind of goes back to Bruce Schneier's comment, it's really, it takes collaboration amongst multiple people. And I think the thing that ISA 99 did that you see in 62443 is defining this into a couple of domains, right? So as a product supplier, or us as Moxa, we have a responsibility to everyone of doing certain things to support certain types of functions within our products, right? That's at the bottom of your page here. Secondarily, those people that take individual products and architect them together into a complete system, you know, whether you are a large organization, have an internal engineering team to do that for your plants and factories, or whether you rely upon systems integrators, or maybe you are a systems integrator, you know, you really have some responsibility to understand how to architect those individual pieces together for that. And the responsibility really even goes all the way up or down to, whichever way you want to look at this, to the asset owner. They need to take some responsibility of making sure that that solution that's delivered to them, they educate their workforce, they educate all of the people that interact with that system, and that security doesn't stop with installation, that the security kind of has other checkpoints that happen to ensure that that continues to be a secure system. It doesn't take much to compromise a system, and that's where these periodic audits will really help with that type of thing. And very important topic that I wish we had more time for today. So part of this is a little bit of strategy. Let me try to paraphrase some of this for you and look at this. We would call this a defense in depth strategy, or is kind of the common industry term for this. And it means a couple of things. One is it's a life cycle process, right? And you kind of saw that in the previous thing, from the supplier or vendor to the systems integrator to the end user. It really has to be throughout that whole life cycle until that plant or facility is actually shut down. It needs to be throughout the whole process with whatever level of security you need for that application. And it needs some monitoring and maintenance with that, and this is really an area where you can really rely heavily on the IT team to help you with some of this. Most of them have some good procedures for that. At the systems design and integration, there's also a lot that needs to be done in terms of network segmentation. So by compartmentalizing what happens on your network, you can keep data from escaping. And there's a lot of different tools and technologies in thinking about doing this, but the basic idea is being able to define physical and logical zones, look at what information has to flow through those zones, clearly define the borders, and define, you may hear the term conduits used. Conduits will determine what information flows between those zones. So it's a little bit more of a logical thinking about what has to happen on your plant floor. And certainly, this is where the collaboration is important within your organization. And that last one, I guess I got ahead of myself, is defining those zone-to-zone interactions, right? This is where you may hear that word conduit used for that. So I think the model is pretty simple to understand, though I understand that it does take a little bit of experience to apply this in your actual application. I want to share with you maybe a little bit of thought or a little bit of an example of that. I know we've got a diverse group here today. I'm just going to use a more of a geographically distributed application. This is one that you might see that might be similar to some of yours for a pipeline monitoring application. So the concept here is remote sites for pumping stations that might be connected via cellular satellite, and maybe having that traffic go over an untrusted network, which could be a public network. By the way, there are lots of interesting technologies from cellular and from satellite to protect that, but it's always good to have the belt and suspenders approach here, right? So you have multiple ways to secure it, and having multiple layers is always a good thing with this. The basic concept is putting a firewall and a VPN in place like this. This kind of demonstrates that segmentation of zones and then being able to clearly define what comes in and out of those. And to go a little further in that, one of the fundamental building blocks of this, and whether or not you are actively involved in IT, I'd encourage a lot of you folks to get a little bit of IT practice. If you don't have a lot of experience in networking, find a way to learn that through your local suppliers, through vendors. Lots of great courses at some of the community colleges now, even some free online learning. Great to learn this. And the basic building block here is a firewall. And firewalls are fantastic, and they're so inexpensive nowadays. And we're talking about industrial firewalls that you can deploy into an application that don't have fans, that are meant for these extreme environments. And their fundamental purposes is to be a traffic cop between what's at that site and externally. And it's a real simple concept. I think a lot of people are intimidated by routers. They hear the IT guys talk about layer 2 routing and layer 3 stuff and all sorts of that. But when it comes down to it, basically all you need to do is think about what needs to happen through this router. And if you look at the bottom of this page, you can see a little bit of the what you're going to set up. You're going to set up a table. And that table is basically going to have one important entry at the very bottom. I probably should have highlighted that. And that basically says, deny everything else. And then on top of that, these items have a higher priority. You say, I want to accept that traffic. So I just realized this one's maybe not the best example. It's using ICMP, which is the protocol for a ping. But let's say that was port 512 for Modbus TCP, and you wanted to allow a Modbus TCP request to come into this site. This is where you can control that. So we use that term accept to allow traffic to come in and drop, and this is kind of the most fundamental thing you can do with a router, and this is just scratching the surface. And you can do a lot of things based upon, incoming traffic, outgoing traffic, what that's based upon, IP address or the physical MAC address, what protocol is, what the port numbers again are kind of like supplementing IP addresses to further define services. Lots of granularity you can do on this. So really easy to do this. Building block on this again is going to be your firewall. Firewalls often get kind of used along with VPNs, and this is an area that, if you have a good IT team, please get to be friends with those guys, and you'll find out there's more that you have in common than different. And the IT guys are really good at doing this type of stuff. Many of you probably use a VPN if you're out of the office and need to have access to your network. So basically being able to use this on a laptop and get into your company resources. But there's also another VPN that's kind of interesting. It's a site-to-site VPN. This basically can take two sites and allow a broader range of traffic to traverse the two networks and bridge those together. This could be useful in a lot of applications as well. Some of the things for VPNs, just to kind of look at a couple things, right? Most of these support, the more popular standards. You'll see IPsec being one, or OpenVPN. Those allow us to basically tunnel. A tunnel is the word of, when you bore through a mountain and are able to have car traffic go in and out through that mountain, utilizing that kind of visual picture of that, moving network traffic across that. And all of these have capabilities to control who has access and what they have access to. And they also offer the ability to hide your data, right, to keep that sensitive data out of prying eyes to do that. So lots of good things with VPNs. Oliver, let's do another poll, please, and let's that'll kind of set us up for the home stretch here. All right, what's our last one here? Okay, we're going to segue a little bit. I think this is a good way to do that. You know, we've talked a lot about some of the remote monitoring, but one of the challenges you guys identified is maintaining this. What methods do you use to troubleshoot network issues, right? Okay, the first one's a little tongue-in-cheek. I don't know if any of you guys, I'm a little bit of a geek. There's a great show called the IT Crowd out of the UK, and they talk about IT, have you turned it off and on again? Is that your approach to solving this? Number two, we send a tech to the site, right? This is the expensive one. You got to put somebody out there, you got to send them out to the site. You know, when we look at some of our customers, a lot of them have pretty widely dispersed assets. That can be a pretty expensive proposition. You know, we file a ticket with IT. Operations and IT work closely together, the fourth one on there. That's great. And last one, and I hope we kind of characterize some of the things, IT shares access to the network monitoring tools. That's a great collaboration model, and we see that as a best practice to some of these progressive companies. Oliver, are we at a point we can kind of share that?
Yeah, let's go ahead and take a look at the results. We're going to share those with everyone in just a second, and here we go.
Sorry, I got to come off mute. I'm impressed on here. It's great to see the responses. Thanks for your feedback, and thanks for sharing it with everybody. I'm really glad to see that fourth one, that we're seeing more of that collaboration between the teams. So that's fantastic. And for those of you that don't have that organization, I think this is good motivation to show you that it can be done. And maybe in the next section you can learn a couple of tools and techniques to do that. I really encourage you guys to collaborate, whatever side of the fence that you're on, to work together on this, because there's some great things through working together. Oliver, let's go back to the slides, and I'm going to go ahead and take us through the last section here, and let's go ahead and move on. This is tip number 5, and I know we've done a lot in a short amount of time, and I think we're doing pretty good for time. Number 5 is, and this one's not obvious, and this is something that comes from expertise and also just in realization. When you're designing these systems, or even if you're upgrading them, think about how you can monitor your communications infrastructure. This is something that IT does very, very well. They have some different ways of doing it, and I think those of us that are not in IT can learn from that and apply those to industrial applications. So let's kind of try to kind of see some highlights of that. And I think us that are responsible for the operations end of things know how disastrous this can be. I think we've all seen various numbers of what downtime costs, whether it's a bottling line in your plant, or whatever that process might be, or the cost of having to throw out a complete batch in our operation if there's something goes wrong. But how can we quickly troubleshoot those? And I think a lot of people think about normal troubleshooting techniques. One of the great things is how can you use your communications infrastructure to give you more about what's happening? I was pretty fortunate. I spent almost 10 years on the IT side of things, working in data centers, and got to learn a lot about what these guys do to maintain these massive server farms and what they do. And there's some really interesting technology. This one's a little old, but still pretty useful. And I've always referred to the operations guys as the Modbus of IT. It's called SNMP, Simple Network Monitoring Protocol, and basically it's a client-server, master-slave type system that has software running on a central PC, and that PC is able to pull those devices and get status. And there's a lot of status you can pull from those devices. Those devices need to have something called an agent. If you're on a Windows-based machine like an HMI, you'd need to run an SNMP agent for that. The software running on the server is going to be called a network management system or network monitoring system. And those generally have something like the dashboard over there that you can see, a heat map or a geographic distribution of trouble spots. Really great technology for doing that. The problem is that SNMP, there's some security issues with that. SNMP also is not so friendly with industrial devices. You talk SNMP to some of us, and it's the deer in the headlights look as to what that is. So if you were to take, for example, a managed switch, remember managed switches have a secondary processor inside, and they're able to actually do a lot of things to monitor what's happening on your network and control network traffic. If any of you are using Ethernet IP on a network, you know how important IGMP query and snooping is for performance. One of the least understood things is all of the data that can be collected by those switches and how you can get it. Here's an example of a lot of objects that are a standard, and we call this a MIB, or part of the database of information management information base that's out there that you can pull. And how about some useful things? How about if you have a redundant power supply, the status of both of those power supply inputs, and you can kind of see how pull response like Modbus is kind of similar. How about if one of those ports on that switch, you guys have all seen the little green blinky light on the back that means you've got something connected, and you know that if that light is not on, you've got a bad cable or the device at the end of it's not been powered up. You know, what if you could monitor that remotely? What about seeing traffic? And what about seeing errors on that traffic? There's a tremendous amount of information in these switches that if you had that could help you more easily troubleshoot these things. The traditional approach, you know, for us factory floor guys and plant guys is, you know, if we've got something that has SNMP, we'd have to maybe put some software in the control room on an OPC server, and then maybe we could bring that to the factory devices. There's a better way to do that. And I just wanted to share with some of you folks that, you know, if you're utilizing the latest generation industrial managed switches, and this is like the best kept secret, most of these support pulling that data from the switch for all of that data in the protocols you already know and love, you know, whatever those might be. So if I took a you know, rotary piston filler in a bottling line, and you're an OEM that designs this, wouldn't it be cool if you could have a maintenance screen on there? So if there is an alarm with something happens on that machine, and you would like to send that operator to a status page that shows something useful, you have the ability to tell that operator that there's something that's been disconnected inside the control panel without even having the maintenance guy have to come over and open the panel and look at it. And that could be simply as something as an overload condition that caused a breaker to trip and causing a VFD to go offline, and when the VFD goes offline, losing that link status on the switch. So some really cool stuff here, and I hope if you're not using that to think about that. Once you have the ability to monitor your network infrastructure, then there's the ability to be able to kind of bring this back to a central dashboard. Whether this, and I was really excited to see in that poll, a lot of you kind of collaborating with IT on some of those dashboards. There are some different needs between what IT does and what happens at the control room and down below. There's a whole category of network management software specifically for industrial applications. There are quite a few and some very capable packages, and these even work and play together with IT very nicely for integration with those. And if you don't know about this, it's worth investigating. Many of these are available for a free download. You can run them on your own laptop and experiment with them. You know, some of the best learning I've done has been on my own time, you know, in the lab, you know, plug some things together and experiment a little bit, right? You know, try out these new technologies before you deploy them on your plant floor. And most of these you can try. Some have like a device limit of, you know, X number of devices that you can monitor. The key things that this type of software will do for you, you can have a visual representation of your network architecture, and you can see status of those connections with color-coded links. You can also be able to click on devices and be able to drill down to what's happening within the device. You can have event management happening. So for example, if there is a event that is kind of critical, you can have that send you a text message to your mobile. And you can also do reporting based upon that. So again, we don't have enough time to go through that in detail, but I think you get the idea. Here's a little more visualization of that. You can see color-coded things happening with those devices on the left under visualization. If you want to get more data about the panel, here's where that unique factory floor automation experience is great. Click on one of those devices and you can get a picture of what that device looks like. Regardless of who the supplier is, they do something like this. And you can see if you look a little closer, you can see some green. Green means that's an active port, and oftentimes you can click into that image a little further to get more detail. And that real-time eventing is nice. And this is the one that's kind of the one that I think you'll find the most useful. If you have an audit log to go back, now when that event happens at 3 a.m. in the morning when you're trying to sleep, it's nice to have this type of system to be able to go back and find out what was the sequence of events to lead up to this condition. This gives you kind of a history, and you know, these simple things, it does take a little bit to set up. Like I said, you might be able to get by with some free software for a while, but the first time you use this, you paid for it, you know, if you decide to employ this type of technology and use it. So really good stuff on that. Okay, we're a little bit behind schedule here, but I think we're okay. Let me just kind of do a quick summary, and then I'm going to ask Oliver for a little help. We'll open up for some Q&A with you folks. But just to think about this a little bit, and I really hope we were able to at least have all of you have a takeaway of one item today. You know, number one, think about, you know, that design for the next application. You know, really think about what that right communication protocol is for your needs, and think about your future growth in that. I realize that it's not possible to have one protocol that does all, and you know, that's never going to happen even, you know, in the future. I think we're always going to be in a heterogeneous environment. But the good news is that a lot of that is kind of started to gel a little bit and distill down to just a couple protocols that are really getting the most attention. So it's a little easier today than it has been in the past for that. Number two, you know, be prepared and know how to handle some of those devices that are the oddball protocols. So the key thing here is don't think you have to go out and spend, you know, a weekend programming to be able to make your own custom gateway, you know, with a communications card in your PLC, or maybe some of you are a little more progressive and know how to do a little bit of coding, you know, writing custom gateways to do that type of thing. You know, there are other solutions out there in the marketplace. You know, you're busy, and your time is worth money. You know, there are commercial off-the-shelf solutions to do some of this stuff and save you a lot of grief. And by the way, there are some gateways coming out now that are able to bridge some of these industrial protocols to even things like MQTT for that matter. Number three, you know, plan and have a plan for those times when Murphy rears his ugly head. So have a plan for those communication disruptions, right? The best organizations, you know, don't wait for the event to happen to design that plan and to have to shoot from the hip. You know, think about some of the more common failure scenarios and have some plans for that, and actually do a little practice for that. And this is the disaster preparedness that I think IT is really well equipped to prepare for and handle, where you can learn a little bit from your IT team. Number four, and I hope, and I'm really encouraged by, again, by the survey feedback here, that so many of you are treating security seriously. You know, it's critical and for so many different reasons, whether it's, you know, for intellectual property that you're trying to protect, whether it's for certifications. You know, some of you may be doing food and beverage applications or food and drug, where you have to have FDA approval, and you need to have audit logs for this type of thing. Security is so important. You know, think about that seriously. Spend a little time. Make sure your management understands how important that is. You know, get education if you don't have that. You know, design it in, and don't let that be an afterthought. And the last one, which is, I think, maybe one that's new to a lot of us, don't forget about managed switches. They've come down in price. They're inexpensive today. There's a lot of features that they're not being used for today. There's a wealth of data that can come out of those. Make your managed switches part of your infrastructure, whether you're an OEM machinery designer, whether you're, you know, a plant manager. You know, leverage that information in to help you more quickly troubleshoot problems. And in a lot of cases, the companies that have adopted this can see failure symptoms before the problem manifests itself. So really good. All right, I've said a lot. Oliver, let me go ahead and turn it over to you, and why don't we open up for...
All right, so we are now in the Q&A portion of the session. We'll try to get to as many questions as we can. So out there, do you guys have any questions for Paul? Are you facing any situations or challenges that were not covered
Oliver, have them kind of use the chat box, right, on
Yes.
GoToMeeting?
Yes. So we have a question here for you, Paul. What is the fastest protocol for communication?
Oh, that's a tough one. You had to ask me tough ones. That's kind of like factory automation. I need to have real-time performance. Everybody's definition of that is different. I'm afraid there's not an easy answer to that, and it really depends on so many variables for that. And I think from a protocol standpoint, I've seen applications with Modbus in well-designed systems with 10 millisecond updates that work really well. I've seen Modbus ones where the design means, you're talking, many seconds, multiple seconds, like 5-second update cycles. It all depends upon your architecture, and I hope that, from some of the things that we've done today, you can kind of get a couple design techniques for that, for what, is the fastest protocol.
Thank you, Paul. Here's another question for you, Paul. Is MQTT being used in industrial applications? And thanks for those questions, by the way. Keep them coming.
Yeah, and I was hoping some people would ask about that. I think, MQTT has really been aligned with Internet of Things, and maybe some of you folks maybe don't like that thing, and it seems very consumer-oriented and commercial. I think a lot of us have been doing Internet of Things for many years. I know for me, I'm a little bit of a veteran here. I did Internet of Things 20 years ago. So MQTT was originally designed for pipeline use. It's gained most of its momentum in commercial deployments. And interesting thing is in the last couple of years, we've been seeing some really interesting applications. Ones that I can point to for direct evidence have been applications in power, specifically for utility-grade PV solar monitoring applications. We've even seen some larger residential deployments of that. Huge in oil and gas for wellhead monitoring. This year there's a project underway with a large food processing organization that's looking to deploy that technology on their factory floor. And I even know of a large application in automotive where MQTT is being used to collect real-time data for analytics. And if you've heard of some of these things, of more of Internet of Things technologies like digital twin or Industry 4.0, being able to compare model information to actual and fine-tune their applications. So definitely being used out there in industrial applications.
Great question. Thanks for that question, and thanks for the information, Paul. We have another question. Oh, we have a lot of questions here. Will IPv6 firewalls work the same as IPv4 firewalls? Paul, can you speak to that?
Yeah, and that's so good to hear people thinking about that. So, most of you probably learned IPv4, which has been deployed, since really the commercial deployment. And we have IPv6. IPv6, the biggest change with IPv6 is at the address space. We ran out of addresses several years ago. It's amazing that we're still able to function without transitioning the whole internet over to it. You just can't shut it off one night and cut over to the next day. So for firewalls and VPNs, fundamentally there's not any big change, though you do want to make sure that the supplier you're working with has IPv6 supports, and that IPv6 support means that it has native support for that. In not only being able to handle that traffic, but able to have the layer 2 and perhaps layer 3 functions to support that. But maybe in short, fundamentally not a big change, but it does require a different software deployment from your supplier. So a good question to ask specifically for new deployments.
Thank you very much, Paul, and thanks for that question. We are running up against time, and I know that we're working with a busy crowd. Maybe one last question. Is Moxa managed switches compatible with microwave communication, since Moxa does not provide microwave? Paul.
And that's a good one too, and maybe something can apply to everybody. I'm going to kind of interpret this a little bit because we don't have your direct audio feedback on that one. All of what we've talked about today has really been relying upon IP technology. So not knowing your actual backhaul for the microwave radios, a lot of the more recent ones are IP native. So if you can do native IP connections, everything we've talked about today will apply. If you're in the unfortunate circumstance, or I think all of us have some legacy stuff, it's not always we can do greenfield applications, there's some brownfield stuff out there. There are accessory modules that you can add to that to add IP connectivity on top of that. A little beyond today's topic, but basically, yes, you can do it. It may need to have some additional hardware to basically bridge IP to those existing microwave radios. And just to give you a little bit of glimpse of that, a little bit like using modems over the phone line, there are ways to do things like that with some bridging technology for that. With that, I'm going to go ahead and let us close here, Oliver.
All right. We're going to have to wrap it up for now. If we missed your question, or if you want guidance on a specific situation or issue, and we did miss some questions, thank you for spending your time and letting us know what situation you're facing out there. But if we did miss your question, you can reach out to us directly at usa@moxa.com. Big thanks to Paul for sharing your experiences, insight on this topic of remote monitoring, and thanks to everyone for tuning in.
Oliver, thanks again, and really thanks to all of you. I know how busy you are. Thanks for spending time with us. We appreciate it, and I really hope you found something useful today, whether small or large. And you will get a little follow-up from us, and please you're welcome to forward this to your associates at work if they'd like to see a recording. I would like to have your feedback. If there's a topic you'd like to know more about, security seemed kind of popular today, let us know and we can inform you of the next webinar on that. And let us know, how we can do other webinars like this to help you in your job to be more successful and to help your organization. And with that, thanks again. Have a great day.